Good evening, friends. We will solve the second problem on block friction. A block is kept on an inclined plane which is 30-degree inclined to the horizontal. The block is kept on the plane, inclined plane. The block weight is 1600 Newton. The block's weight is 1600 Newton. Acting down. Always the weight will be acting downwards. And the block is pulled vertically parallel to the surface. The block is pulled parallel to the surface with a force P. What is this force P? If mu is equal to 0.2, mu is equal to 0.2. So that is the question. So how to solve this? It is similar to the previous problem. So what you have to do, you have to consider the contact surface as x-axis. Previous problem also we have considered the contact surface as x-axis. Similarly here, you consider the contact surface as x-axis, perpendicular to this as y-axis. So the block is pulled upwards, there will be a downward frictional force. Okay, in the negative direction, there will be a downward frictional force will be acting. What is that? That is 0.2 into n. That is mu into n. Mu is 0.2, n is the normal reaction. So normal reaction, how it will be? It will be normal to the contact surface. Contact surface is this. The normal reaction is this, n. Now you can see in this problem, this point to n is parallel to x, aligned to x, p is aligned to x, this n is aligned to y, but this 1600 is inclined. How much it is inclined? So you can see the same inclination what the surface is having, that inclination it is having to the vertical 30-degree. So this 1600 I can resolve it into two components, that is, one is 1600 cos 30-degree, another one is 1600 sin 30-degree, that is horizontal component. So what is 1600 cos 30-degree? That is 1600 cos 30-degree is 1385.64. 1385.64. This 1600 sin 30 is 0.5, so it will be 800. So now I have all the forces here. So what you have to do, I have to draw a free body diagram, that is, this is x and this is y. The block I am considering it as a particle. So there will be a downward force from the block, the downward force that is along y-axis, y-axis is here, along y-axis the downward force is 1385.64. Along y-axis the upward force is n. Along x-axis the horizontal force is P. Along x-axis the negative horizontal force is 0.2 n plus one more component I have, that is on the negative x-axis, that is 800. So coming to this, how to solve this? This block is nothing but a particle in two dimension, which is in equilibrium, right? So I can write the summation of f of y is equal to 0, one equation. So f of y component, if I take the n minus 1385.64 is equal to 0. So n is equal to So n positive minus 1385.64 is equal to 0. N is equal to 1385.64 newtons. So n I have got. Then coming to the second equation, summation of f of x is equal to 0. This is the another equation for equation of particle to be in two dimension. That is 0.2n p minus 0.2n minus 800 is equal to 0. So my p, by substituting this n to here, the p value will be 1077.128 newtons. So this is how I have to solve an inclined plane problem. Thank you.